ओके, स्टार्ट करते हैं।
Yeah, hello. Good afternoon, everyone. Today, I welcome to the webinar series on industrial aspects of thermal engineering conducted by Lokmanya Tilak College of Engineering and in collaboration with ISRE Mumbai chapter. Today, in the day 4, we are having the topic of basics of air conditioning and VRF, which is conducted by Mr. Sanjay Verma. So, I'm very much glad to welcome Mr. Sanjay Verma today for the session of basics of air conditioning and VRF. Sir is managing partner Sara HVAC Systems and having mechanical engineering background with MBA in marketing from University of Madras. He is having 22 years of rich experience in the field of HVAC industry at various locations. He is founder of Sara HVAC Systems, a Mumbai-based HVAC system provider company. He was involved in the execution of various green buildings and prestigious projects during his career as employee. It includes turnkey HVAC projects for numerous industries like BPOs, softwares, hospitality industries, and many more. At present, he is serving ISRE in many perspectives like treasurer, secretary, student activity coordinator, and K-12 chair at various timings. He is serving as membership chair ISRE Mumbai chapter for the year 2020. Again, I welcome you, sir, and request you to proceed for the presentation and enlighten us. Thank you, sir.
Good afternoon. I am audible?
Yes, sir.
Good afternoon, everyone, and warm welcome to our all students. I personally thanks the entire team of Lokman Tilak College of Engineering, the Chief Patron, Sri Satish Sahab, Principal Vivek Sir, convener for this program, Dr. Kavita Dhanwade Madam, coordinators, Professor Shweta Mate, Professor Mahesh, Professor Ajay, Professor Smita, and Professor Sanish Rao, and Neha Madam. I'm glad to be here today, and I will be presenting basics of air conditioners. And in later stage, I will be going for VRF systems. Before going to that, I would like to say a few sentences, maybe a couple of minutes about ISRE. It was established on 1981, and presently ISRE is having more than 28,000 members. Especially for the student community, I would like to say a few things for joining the ISRE. ISRE is a premium technical society exclusively for HVAC and our community. ISRE membership for individuals only, no corporate membership. This provides excellent networking opportunity to interact with other professionals, industry leaders, and key decision makers in the profession of the industry. ISRE provides an excellent forum for professional development and continuous training and retraining on both fundamentals and latest product and technology available worldwide. ISRE also provides a platform for effective marketing and launching of new products and technologies through exhibitions, products, presentation, and advertisements. Member who is having the ISRE valid membership, they can easily access entire ISRE technical publications, software, workshop, conference, and training programs. This also gives opportunity to work in chapter working committee and headquarter activities towards the mission to promote the arts and science of HVAC and R in India. And there are a lot of other tangible benefits for the ISRE members. For the students, basically, they used to get 1,500 additional discounts to become full-time members. They have to pay just 3,000 plus GST, that is 3,540 rupees only to become full-time members. Once they are passing out in the month of June or July, when they get the result, from that time they will get the extension for 3 months. And within the 3 months, if they are continuing to become the full-time members, they will be charged only 3,000 plus GST for 3-year membership. So students, if they are seriously looking towards HVAC industry, they will get a lot of tangible benefits. And I urge the college community team and entire ISRE committee team from the college to call all the students to join up. This is all about ISRE. Presently, since I am membership chair for ISRE Mumbai chair, ISRE Mumbai chapters, that is why I have spoken a lot of things about our membership. Should we wait further or should we go ahead for presentations? I would like to make more uh, communicative session. Should I still wait for joining someone or should I start presentation?
You can continue. It is live on YouTube.
Okay. I would like to share my screen once again.
Okay.
Students will be joining across Mumbai or across anywhere?
All over India, sir.
All over India. Welcome to the world of air conditioning. And I once again thanks Lokmanya Tilak College of Engineering team and convener for this program, for this webinar series day 4. And the topic for us is basic of air conditioning and VRF systems. These are my contact details. First of all, the basic thing, what is air conditioners? Broadly speaking, air conditioning can be defined as the process of treating air so as to control simultaneously its temperature, humidity, cleanliness, and its distribution to meet the requirements of the conditioned spaces. Although the primary objective of air conditioning is cooling, the term air conditioning has much wider meaning as it's described in the definitions. इसका मतलब ये होता है कि हम एयर कंडीशनिंग की अगर बात करते हैं तो एयर कंडीशनिंग का यही केवल मीनिंग नहीं होता है कि हमने जस्ट कूलिंग कर दी है अपने रूम को या अपने ऑफिस प्रीमाइसेस को. हमें बाकी चीज़ों की भी ख्याल रखनी पड़ती है, लाइक ह्यूमिडिटी एंड क्लीनलीनेस ऑफ द एयर, distribution of the AC has been made properly to the entire area. The few types of air conditioners I have tried to summarize the names, which is very popular and many people will be aware and many people may not be knowing a lot of things. This is window AC, split AC, cassette AC, tower AC, modular AC. Nowadays it is very popular for the functions and all. Ductable AC, package AC, and today whatever we'll be talking, that will be VRF systems, chiller system, and DX systems. I have just summarized this so that it will be very easy to go further one by one. We will not be covering much on window, split, cassette, tower, modular. Just I will give the basic definitions of that. This is a look of window air conditioners and split air conditioners. The cassette air conditioners, tower AC, the portable AC, ductable air conditioners, package air conditioners, VRF air conditioners, chiller air conditioners. Few sentences about window air conditioners. This is single unit with compressor and condenser, mounted only in window frame. No need to making hole in the wall. Easy to install, mobility and shifting. More noise level because the compressor comes in single box compared to split air conditioners. When you stay in a rented accommodation and you frequently change your home, window AC is comparatively better and easier to carry out. High wall air conditioners. The AC units consist of two parts. One will be evaporator unit, which is inside the room, and other is condenser unit, that is compressor unit, which will be outside the room. And mounted on the wall, need to make holes in the wall, and this will be connected with copper piping. There will be less noise level compared to window air conditioners because the compressor and condenser goes outside the air conditioned room. This is good choice for cooling medium for large space. The third things are coming cassette air conditioners. A cassette AC is one of the type of ductless mini split systems. In this system, the indoor handler is not installed on wall or floors. Instead, it is installed in the ceiling with a ceiling cassette cool air distributed from up to 4 sides of the cassette unit. Presently, we have the options like we can give one sided through also, two sided through also, three sided through also, and all 4 sides through also. This system will be installed with the ceiling so you can get proper cooling all 4 sides. The other part is, the next one is tower type air conditioners. This is similar as floor mounted air conditioners. Floor mounted air conditioning units provides a unique advantage in that they can installed in any locations anywhere. No wall is required, no ceiling is required, no space is required. This can be installed anywhere at floor area, and this is very good for the application like cafeterias, stores, large reception room, hotel fires, and common rooms. The other thing is ductable split air conditioners. These systems can be installed above the ceiling, with the ceiling. A ductable air conditioner is a split air conditioner in which air conditioned air from the indoor unit is passed into the room using any type of duct, either circular, oval, rectangular, and duct can be fabricated either using galvanized sheet or pre-insulated sheet or fabric. And the duct will be running from indoor machine, that is from this evaporator unit, and this will be running across the offices area or whatever premises it is. Through air grills, we will get the chilled air, and this condenser unit with compressor fans, this will be installed outside. A ductable air conditioner is normally installed either above the conditioned room or outside. Return air is collected from the room and is passed back to the air conditioners. This is near to our indoor unit. The space where the air is conditioned and the room are always kept airtight except for some measures, volume of fresh air which is needed based on defined ventilation standards. The next type is floor mounted package air conditioners. The package AC system is completely enclosed system which is almost always placed outside the building with its separately supply and return air ducted into the building. The big photo what you are seeing here, this is the floor mounted package AC. This will be kept in the closed room and the duct will be mounted from the top of this machine. And again, we can run the duct in our conditioned area. The other condenser unit will be kept outside the room. The floor unit, the indoor unit consists of blower, evaporator coil, filter and compressor. And we'll have just condenser coil and propeller fan for our outdoor units. And the next is chillers air conditioners. This is largely used for the commercial space, shopping malls, hospitals, and bigger areas. The chiller is a machine that removes heat from a liquid via vapor of compression or absorption refrigeration cycle. This liquid can be circulated through a heat exchanger or cool equipment or another process stream. They are often air or water cooled. This is available in either air cooled or water cooled. Will not be going in the deep. Just I have given the reference and little bit of definitions for all the air conditioning systems. And the topic for the day is VRF air conditioners. I know I'm talking on this college platform. Many of our mechanical department HOD professors will be there. Our students will be attending the RSC classes in their 6th semester hope nowadays. So they will all have already their lot of theories. There are all the formulas, all the vapor absorption cycles, air cycles, all these things, the refrigeration cycle in their chapters, and the professor will be teaching all those continuously. So I will not be going to deep into all these formulas and sums basically. I'll be giving you the overview of the VRF air conditioners at present scenario in our HVAC industry, or maybe away from college, that is corporate worlds. And my presentation will be basically what is variable refrigerant flow, what is VR, how do we use VRF system, how the VRF IDU, ODU, and it is configured, the VRF indoor-outdoor schematic details, VRF ultimate solution and the benefit of VRF, different types of VRF systems, and at the end, some comparison with conventional systems. The VRF, whatever figure images I am showing, इसमें किसी भी मैन्युफैक्चरर का कुछ लेना देना नहीं है, and I'm not promoting any of the brand basically at this platform, but I have taken some images from some of the manufacturers. This is just for educational purpose. Basically, VRF system was launched in 1982. One of the Japanese company launched VRF systems, and they have got the patent name with the name VRV. Whereas other than the particular Japanese company, all other company says this one as VRF, variable refrigerant flow, is also known as variable refrigerant flow, and in other words, that is VRV, is an HVAC technology invented in 1982. This is like ductless mini split VRF, use refrigerant as the cooling and heating medium also wherever it is required. It introduces the world's first use of variable refrigerant flow control. This technology circulates only the medium amount of refrigerant needed at any one time and enables individual climate control of air conditioning zones, minimize the refrigerant path, allow for maximizing the efficiency of refrigerant work. VRV, the meaning of VRV is variable refrigerant flow volume, and VRF, variable refrigerant flow. So why do we use VRF system? The VRF system, it decentralized system, like zone-wise comfort we get, the efficiency, pay for what we use. It is not like, the area which is not used, we are paying for that. Then flexible as desired capacity wise, simple to design as compared to central air conditioning, and easy to install and commissioning as compared to central plants. Good value due to latest technology and control systems. I have shown some photos here, some images here. The VRF outdoor unit configurations. This starts from 4 HP even nowadays. Earlier it was from 6 HP, but nowadays it is 4 HP to 12 HP capacity. And this comes with side discharge. And this system is widely used for residential bungalows and small office premises. This is side discharge system, which you can see here. ये फर्स्ट वाली जो इमेज है, और उसके बाद उससे जब आगे हम बढ़ते हैं, that is from 8 HP to 28 HP for commercial premises. Again, it differs from manufacturer to manufacturers. Some manufacturers is having 8 HP to 24 HP single outdoor machine. Few manufacturers are having till 26 HP for commercial premises, and one of the other Indian multinational company, they have up to 28 HP for commercial premises. That 28 HP will be the single module of outdoor VRF systems. We can add 4 modules together to get the maximum capacity. It means 28 HP maximum capacity available in the market into 4. So this much the single machine can be used for the bigger commercial premises. And as far as indoor unit configuration is concerned, we have various options with VRF systems. For the residential use, we use high wall units, and we have the options available from 0.8 TR capacity to 2 TR capacity. And the cassette with 4-way supply, with 2-way, 1-way, as well as compact cassette. Also, we have available indoor combination for this. Compact cassette comes in fact of 0.6 ton capacity to 1.5 ton capacity. It means we can use the smaller capacity for our small users, small areas. We have the other combination available, which I have shown. One is vertical model, that is tower type of air conditioners. Also can be connected with VRF systems. The concealed units also can be connected with VRF systems. This is very much popular, widely popular in hotels for their guest rooms. Then other small areas, like in maybe the bungalows, in your drawing house. Suppose you want to show the look as central air conditioning, you can use as concealed split inside and connected with the outdoor VRF systems. Ductable machines for the higher capacity, and again floor mounted package air conditioners for again higher capacity, like bigger commercial premises, showrooms, malls, and many more. Presently, we can use even AHUs, air handling units. Our friend Sanjay Jadhav had a session couple of days back. So he had given very nice presentation on AHU's technologies. So AHU technologies can also be used along with VRF configuration. AHU again, that is available with various capacity, the smaller capacity with the larger capacity. Since we have options to bring 28 HP into 4, 112 HP capacity. So in the configuration of that, I mean, we can accommodate from 1 unit to up to 48 units along with the outdoor units. This is one schematic I have shown for VRF systems. I have shown the maximum capacity for outdoor units of different capacities can be clubbed together with either heat recovery ventilation systems or TFA units, or these two are optionals, whereas we can install any of the systems along with these outdoor units. It's our choice, it's customer's choice, the high wall AC, cassette AC, tower AC, or concrete unit. And at the end, you can see here air handling unit also. So the look of a VRF system, I have shown the schematic diagram here. We can keep our outdoor machine above the terrace or maybe away from the air conditioned area. We can club 4 systems together, or either one system or either 2 systems or 3 systems based on our requirements, based on our design. From the combination of 4 outdoor machine, we can do the air conditioning for either for 1 floor, 2 floor, 3 floor, or 4 floors, depend on again indoor capacities of cooling load. We have the options from one machine, we can, I mean, even cool 1 floor or even 2 also. There is no limitations. Another schematic I have shown here, I have shown with one machine and the section of the office where you can see this is something looking like conference hall. This is some workstations area, then some cabins and many workstations. We get a good price value. The VRF is the ultimate solutions. Why? Because of their efficiency, because of flexibility. What I have shown earlier slide, the flexibility meaning many indoor units we can connect with the unit. At the same time, even outdoor units also. Versatility and modernity, which I will be showing further. So, variable refrigerant flow is a central air conditioning system in which refrigerant flow is varied depending upon cooling requirements. This is a filling of the central air conditioning, heat load of system. So, variable refrigerant flow effect is achieved by inverter controlled compressor, electronic control expansion valve, and microprocessor based controls. I'm not going much fast. Hope I am okay.
Yes, sir, it's fine.
Then I have shown here 3 type of loads basically for VRF. One is all inverters, that is the right side, with 100% load how it will work, with 50% load how it will work. The second left side corner is partial inverter. Nowadays machines are coming 100% inverter compressors also. And the left side is digital scroll compressor. This is based on the compressor configurations and capacity of the outdoor machines. The load varies, power consumption varies based on your consumption of the air conditioners. And the working principle is something here like that. We used to give the power supply to the systems, and this box is inverter box. This controls the entire signals for the systems, and finally this gives a signal to the compressor inverter output. The schematic is very clear. Thus the speed of a compressor is varied depending upon the load achieving variable refrigerant flow, which I said if I have 10 machines in the systems connected, if I am using 5 machines, so the whatever load, indoor load is there, so total load will be, refrigerant will be varying based on the internal load. There is one small formula for this RPM, which you will be, the students will be studying basically in the 6th semester in their RSC, basically calculation of RPM. This is a formula I have shown here, how to calculate RPM. So in this images, in this graph I have shown, the VRF is the ultimate solutions. I have shown two figures here. One is conventional technology, the left side the diagram, and the other side we have shown the room temperatures with this. The first diagram is on-off type cycling causes wide temperature fluctuations with conventional technologies, whereas the superior power and precise control for maximum comfort and energy efficiency due to this inverter technologies. Again, what happens in the case of fixed compressor or maybe the standard air conditioners, we used to get a lot of fluctuations in there when the machine is running, cutting off in all these durations. Whereas in the case of inverter technologies, the compressor runs very smoothly, and this goes to their 100% design capacity. And again, it varies based on the indoor loads. So by using all inverter driven compressor, VRF is able to significantly reduce the electrical and mechanical stresses that are placed on fixed speed compressor during a startup, and friction between two pipes are lesser. Now, I am going to show some advantages for this. So, advantages of inverter control compressor. What happens basically, the compressor speed is varied, thus achieving a smooth control of refrigerant flow based on your indoor load requirements. Less energy consumptions because of part load. I'm using suppose half of the units. So the power consumption will be, energy consumption will be based on only that much equipment. Highly efficient system as it works on demand and supply. If we are increasing our outdoor unit more in operational, so again the energy consumption go up. But with again the system will be a highly efficient system because this is not the fixed system. This is with inverter controlled compressor. Then variably works on part load condition. Maintains uniform temperature. You will have the remote setting with you. You can set the temperature based on desired temperature. This works. And very low starting current. this inverter compressor is made in such a way so that you have the soft start for this system. Uh, those days, the air conditioner was consuming about 1.4, 1.5 kilowatt per ton in running condition. But again, in a starting, it takes about more than 20 to 30% higher. But nowadays, with this inverter compressor technologies, the initial power consumption also has come down. At the same time, it is soft start. So we do not need 40% higher energy for initial start. Very low starting current, low operational sound due to highly technical design compressor, compact in size, thus a smaller unit body, and this occupies less space, less footprint for our outdoor machines, and this can work up to 3% of its rated speed capacity and achieves individual's controls due to various indoor units, due to a lot of indoor units based on your desires. Now, someone will ask, is it a split unit? Yes, it is a centralized split unit system minus the drawbacks of the split units and advantages of central plants, because we are going to save location for many outdoor units, which is coming for the split AC for the smaller systems. Then the second question, is it a central plant? We can say yes, it is a central plant, but again minus the drawbacks of chilled water plant, where we need larger place for the central plant, and again advantages of a split units, like indoor unit we have the smaller capacities. So this is the best combination. The VRF is the best combination of split unit, and this is the best combination of even advantages over central plants. So this is best of both the systems. Again, some advantages over conventional split unit system. Single outdoor unit can connect up to 48 number of indoor units. In the VRF system, we can connect up to 48 indoor units. Indoor units means the air conditioned area unit. And that too, we can have any designs systems, that may be the high wall split AC, that may be the cassette AC, that may be the ceiling suspended ductable unit with the configuration of outdoor machines, or as per your wish. But we can maintain outdoor location at one place, probably the combination of 1, 2, 3, or 4 outdoor units, but clubbed together at one place at one outdoor locations. Whereas if we are talking for the split unit, all 48 indoor units will have 48 outdoor machines. What will happen? We need 48 locations for keeping the outdoor units, which we are going to minimize at one locations here. So this is major advantages over conventional split unit. We are going to save huge space, which is very important. आजकल तो मुंबई में जो घर मिलते हैं उसमें तो जगह ही नहीं मिलते हैं एसी डालने के लिए. तो अगर हम 2-3 बेडरूम के अगर बंगलोज वगैरह लेते हैं, तो उसमें अगर हम एक VRF सिस्टम, जो मिनी VRF सिस्टम कुछ कंपनियों ने अभी नए इंट्रोड्यूस किए हैं, या रेसिडेंशियल VRF सिस्टम जिसको बोलते हैं, दैट इज वाइड पॉपुलर, वेरी मच पॉपुलर. 2 बेडरूम हो, 3 बेडरूम हो और हॉल हो, सबको अंदर के यूनिट कनेक्ट कर देते हैं पाइपिंग से, एंड ओनली वन आउटडोर यूनिट विल बी केप्ट एट वन लोकेशंस एनीवेयर. So you can save the 3 or 4 locations which you are going to keep the conventional split unit. That is avoided. That you can save the locations. You can save the valuable space. Again, The system can work in part load condition. For example, in a bungalows, we have installed the VRF system. What will happen? We have one outdoor machine consisting of maybe 5 units above first floor area and 5 units at ground floor areas, serving with some bedrooms, halls, some dining areas. If you are using only ground floor area, your power consumption will be based on only ground floor area, not for the first floor area. So this system works on part load condition, not for the 100%. Less power consumption because of our digital compressor and nowadays inverter compressor. Overall COP is very high. Coefficient of performance is very high, which is very important for long run. Sometimes what happens, customers or maybe uh, whoever is the users, they used to decide कि नहीं बाबा ये तो बहुत कॉस्टली है, एक काम कर थोड़ा सस्ता यूनिट डाल दे. तो उस केस में क्या होता है कि वी यूज्ड टू गो फॉर द स्मॉलर यूनिट. तो इनिशियल कॉस्ट जो कैपेक्स होता है, कैपिटल कॉस्ट जो होते हैं वो तो कम हो जाते हैं. लेकिन क्या होता है, अगर हम एक कंपैरिजन करेंगे, अगर एक बंगले में हम 10 एचपी की VRF डाल रहे हैं और दूसरे में 10 एचपी के सिमिलर कैपेसिटी में हम अगर इंडिविजुअल स्प्लिट कन्वेंशनल स्प्लिट ऐसी डालते हैं, तो और पावर कंजम्पशन अगर सेम ड्यूरेशन में अगर आप देखेंगे, परफॉर्मेंस वाइज अगर आप देखेंगे, देन इन दैट केस योर VRF विल बी बेटर. And the next point is this can accommodate very long length piping up to 175 meters. Here I am putting this is conditionals. मैं इसके बाद में एक और भी प्रेजेंटेशन का स्लाइड शो करूंगा जिसमें अलग अलग डिपेंड ऑन फ्लोर्स, डिपेंड्स ऑन वर्टिकल, डिपेंड्स ऑन हॉरिजॉन्टल हाइट्स. The piping length varies based on that basically. But we can go up to maximum piping length. This is not possible in the conventional split AC. उसकी एक लिमिटेशन होती है कन्वेंशनल स्प्लिट एसी की कि हाँ हम 5 मीटर तक कॉपर पाइपिंग कर सकते हैं, 10 मीटर तक कर सकते हैं. अभी तो खैर उसमें भी इन्वर्टर कंप्रेसर, इन्वर्टर टेक्नोलॉजीज की स्प्लिट एसी आ गई है. So we can go up to maximum 25 to 30 मीटर ऑफ कॉपर पाइपिंग. अगर हमें लोकेशन आउटडोर रखने के लिए नहीं मिले, इंडोर और आउटडोर के डिस्टेंस अगर 20-25 मीटर से ज़्यादा हो गए, इन दैट केस वी कैन नॉट यूज द कन्वेंशनल स्प्लिट यूनिट. सो इन दैट केस आवर VRF सिस्टम विल बी very good system for that. This system offers inbuilt redundancy. This system can work in diversity. Very user-friendly system because of their controls. ऐसा नहीं है कि हाँ ये VRF सिस्टम है तो हम ऑपरेट नहीं कर सकते, ये बहुत सारा कुछ हाई फाई टेक्नोलॉजी होगी. This we need some professionals to operate this. No, any layman can operate this because you have the digital display with your remote. Just with the remote you have to operate your all the systems. I have prepared one small advantages over VRF over air-cooled chillers. Work on a direct expansion mode, no intermediate mode of cooling, higher operating efficiency, no accessories like pump etc. are required. In the case of air-cooled chillers or water-cooled chillers or central plants, we need to install the secondary systems, which is a primary pump, secondary pump, or maybe in the case of water cooled, the cooling towers and many other systems. So, I mean, the intermediate mode of converting converting the standard water to the chilled water, then this goes to the medium of AHUs. Then this comes to air conditioned area. So no accessories required. Auto redundancy available in models. More variety and ranges of indoor units with connectivity up to 135%. Each module works on DC sine wave inverter. हमने इधर 135% लिखी है. It means we can go the diversity up to 135%. अगर हमें 10 HP की जरूरत है किसी पर्टिकुलर बंगलोज में या किसी पर्टिकुलर ऑफिस में, तो हम उससे या वाइस वर्सा 135% में उसको डिजाइन करके हम इंस्टॉल कर सकते हैं सिस्टम को, एंड दैट विल वर्क ऑन डीसी साइन इन्वर्टर. It delivers exactly the required capacity. This can work 3% of its rated capacity, easy in installation. Special room for AHU not required for this because we are using the smaller units, indoor units for the conditioned area. Starting current for VRF is very low compared to chillers. Again, it varies from manufacturers to manufacturers. But in the case of chillers or central plant, definitely you need initial power consumption very high as compared to our VRF systems, because a lot of other equipments, as I said earlier, the pumps, cooling towers, and many other systems will be working initially to run the systems. This is a COP comparison. I have made it for air-cooled screw chillers. The green one is chillers. At 100%, the COP is below at 3% basically. The 80%, 70%, 60%, and 50%. You can see when we are coming to the part load, the COP for the VRF is getting better as compared to chillers. It means the VRF is very good on part load because of less equipments, and this comparison is made for 120 TR chillers and again 48 HP into 3 numbers of VRF systems combination at 35 degrees Celsius. That is DBT outside. And this comparison is between only for chiller unit. There are other accessories which is not added here. The chiller will be having the pump, the cooling towers, and many other things. That calculation is not added here. Once that is taken, the COP will decrease for the chillers by 10%. It means the COP for our VRF systems will be much more higher as compared to screw chillers based on this performance chart. How we do the piping connections. This is very, very important basically. From designing point of view, designing of the VRF systems. आप जानते हैं कि जैसे हम एक रेसिडेंस में अगर 1 स्प्लिट एसी का इंस्टॉलेशन कर रहे हैं, in that case what happens? The one indoor unit is connected with one outdoor unit. But in the case of VRF systems, we are talking as many as indoor units. Then how will do the copper piping? How the copper pipe will be segregated with a lot of indoor units? We have software. We have, meaning every manufacturer is having their standard software for design calculation for their copper pipe sizings. The copper pipe again sizes varies based on the capacity, based on the first indoor unit to last indoor unit and the capacity. The copper pipe coming from outdoor machine, which I had shown earlier, again I will be showing in this sheet also, this slides also. The copper pipe branching will be connected with one pipe connector that is called a refnet. You see here. This is the outdoor machine models of VRF. This is top discharge for higher capacity. The copper pipe comes from outdoor machine, and this place you can see there is one white type of copper pipe joint. This joint is called as a reference joint. From here, either the suction line or the liquid line, both can be segregated with putting one as header and other as branches for their various indoor units. And this will be installed. The copper pipe sizes varies. The starting of the copper pipe size with this outdoor unit will be based on the capacity and software calculations. But the copper pipe, as we are going further, the copper pipe size goes decreasing based on the indoor unit installations. Again, when units are in line and distance from each other, bridging access is not a problem. What happens? We do the bridging with this referent joints with all the copper pipings. And while doing the bridging, there will be nitrogen flow, and we'll be doing the bridging so that the particles coming from bridging should not enter to the copper pipe. It should get flushed continuously. So advantage tends to use less piping, and this advantage tends to have more bridging joints. Joints are relatively expensive. I am showing another piping connections here. Earlier you have seen was with one reference joint, one Y type of joint, but there are systems, some of the manufacturers is having, they can run single pipe, and from that single joint, they can take 4, 5, 6 joints from one place itself. So what will happen? This initial copper piping length can be minimized, quantity can be minimized, gas quantity can be minimized while gas charging, and from these joints, all the indoor unit will be connected through copper piping. But this is with few manufacturers. When units are in cluster and relatively equidistant from each other, bridging access is some areas may include multiple Y joints. And the advantage is less connection to bridge here. See here, I mean, in the earlier slide, what you have seen is many Y joint. It means many bridgings, but here we have less bridging. Collectively, less expensive than Y joints. But disadvantage with this system is tends to increase piping length for the indoor units, may add refrigerant charges. This is what earlier I was talking. Now we can, the VRF systems can be installed with actual length of indoor unit and outdoor unit will be 180 meter also. The length, the outdoor unit can be kept on terrace, and we can take the indoor units 180 meter below the terrace also, the floor level, whatever it is. And the farthest length for first branch to farthest IDU, that is indoor units, can go up to 90 meters. And overall, for all the indoor units and outdoor units together, the sum of liquid piping can go up to as much as high, and at present scenario, few manufacturers are giving up to 1000 meters, which is very big meters length quantity wise. So we can do the air conditioning with VRF systems up to 180-meter height building also. Now coming to some little bit of modernization, the building management systems. The entire air conditioning of VRF systems can be controlled from either with the desktop, that is BMS system, sitting at one place through plant managers, or maybe you can do the programming at one place, and then the same app can be downloaded to your smartphone. From there you can see which system is functioning, which system is not functioning. Some of the manufacturers having touch controller systems, most advanced. Some of the manufacturers is having less advanced basically. So what happens if you see this basically? Some of the manufacturers, I said the wording. So this company is having iTouch controller. They can control up to 32 units of outdoor machine. 16 outdoor unit from this one iTouch controller. Here itself they will plan and they can control 16 outdoor units, and 64 indoor units they can control from this one. Again, it depends on their models. We can do the different type of programmings. We can do the time schedules. We can do the temperature schedules. We can do holidays schedules. Many corporates, many commercial complexes, the central air conditioning will not be working all the times. This iTouch controller is having the programs. We can do the holidays program. What will happen Saturday, Sunday, suppose AHU is not working, we will set the program right across. The VRF system will be working full day 24/7 basis for Saturday, Sunday. Again, once the Monday, the plant is operational, based on this program, this iTouch program, this system will cut off, and again central air conditioning will be serving for their critical areas like server rooms and all. This is all possible with the latest technologies. And we have another type of inverter controller systems, the iTouch controller, where we can control 128 indoor units and maximum up to 32 indoor units, up to 64 zones setting, alarm setting, weekly schedule, which I was talking for, and with master controls. Everything is possible at present technology scenarios. Thank you for listening us. Thank you for your kind attention. I was a little bit more theoretical side because I was knowing that a lot of formulas and theorems will be taught by our teachers in the colleges. So something in HVAC industry, which is the latest technologies coming up in HVAC and in VRF systems, so I have gone more towards that. Thank you for your attention and listening me. Any questions? Definitely we'll have some questions. Thank you.
Yeah. Sir, thank you very much for the exhaustive actually elaboration on the various topics of HVAC and VRF also. So definitely audience definitely get benefited by the particular elaboration or the presentation which you have given. So definitely we have to move towards the question and answer session. So over to you, Michohan, for the question and answer session.
Okay, thank you so much, sir. Our first question is from Ajay. For effective cooling with cost effective and comfort with AC, is residential space is recommended?
Again, it depends on sir, residential he is asking. It means again it depends. वो या 2 बेडरूम है के हैं रेसिडेंशियल, 3 बेडरूम के हैं, 4 बेडरूम के हैं, बंगलोज हैं. But precisely, if I'm talking for the air conditioning wise, definitely the initial cost will be little bit higher, probably 20 to 30% higher in the case of VRF systems. But with the technology, inverter compressor technologies, and with the latest updates, I personally suggest to go for VRF systems for your residential air conditioning requirement also, because you will be saving huge space for keeping your outdoor machines. And it's not like, I mean, if you have installed one machine, so power consumption will become higher. No, I have said we have the power consumption will be having based on our indoor unit usage only. So truly speaking, as per my suggestion, I suggest to go for VRF systems at present scenarios.
Okay, thank you so much, sir. Now, other question is from Mr. Siddhappa. Generally, cassette air conditioner are double the cost of split air conditioner for the same capacity. Why?
Yeah, very nice question. Sir, what happens? The air conditioner manufacturers used to bring many materials which is not available in India. So they used to bring from abroad, from many other countries. It is, but slowly it is passed now. The equipments molded and the sizes of the cassette AC is larger and bigger as compared to our high wall air conditioners. One thing. Second, the cassette unit is having inbuilt facility where we have inbuilt pump. What it does, we know the condensed water goes away from air conditioned indoor unit to outdoor areas wherever we are giving location path them. So the cassette unit it is having inbuilt pumping facility also. This cost is approx 8 to 12% of the total cost of the cassette AC basically. This is not available with the conventional high wall split unit or window air conditioners. So many costly parts, the remote controls are little sophisticated. Due to all those features, basically the cost goes up for the cassette air conditioners.
Okay, thank you so much, sir. Again, from Siddhappa, sir, which is the most unique advantage of VRF technology, and what is meant by 3 pipe and 4 pipe VRF system?
I have not shown basically the image for 3 pipe and 4 pipe systems basically. Mostly in the case of VRF systems, simultaneously heating and cooling if it is required. We use 4 pipe systems, which is mostly not applicable for our west zone and at this location, basically this Mumbai and all. This is applicable for the hill stations and the lower ambient places. So this can be used, the 4 pipe systems can be used and designed for these VRF systems.
Okay.
Design criteria remains the same. The piping capacity, piping sizes remains the same based on your indoor capacity requirements.
Okay, sir. So Now now a question from Fuzil Khan. He's asking which type of compressor is used in VRF system.
I have said presently many manufacturers are using inverter compressor. The compressor will be manufactured by the compressor manufacturing company. Basically, Daikin is having their own. Many other companies, Hitachi is having their own, but many company used to purchase from other manufacturing company. But they are using nowadays inverter compressor in the case of our VRF systems, which is latest technology compressor, and the silent in operation. The sizes of the compressor are small as compared to our earlier compressors. The initial power consumption is less. The running power consumption is less. Although advantages are there, many other advantages are there, which is better. Like this inverter compressor is better nowadays.
Okay, sir. Sir, I would like to please stop the screen sharing from your side. Your view is small. That's why.
One second.
I'll by that time
Yeah,
I'll read the
I have
next
done.
question. Okay. So Ajay is asking you a question. How can how can we control the compressor speed for 3% rated speed for smooth control flow?
We need to have the special classes for the compressor basically, but see, the inverter compressor is designed in such a way so that this senses your indoor unit load capacity, and this senses and this gives commands to your compressor from indoor unit. Based on the command, our compressor works basically.
Okay. Now there is a question from Divyakar. Uh, so does that mean the VRF piping cost increases? Like someone asked why copper pipe. So Fuzel answered thermal conductivity. So Divyakar is asking, does that mean the VRF only piping cost increases?
No, there are many criterias. There are many other parts basically. What happens? Uh, Suppose we are using VRF systems. Only one outdoor we are keeping at one location, and from there we are running copper piping to each and every locations, each and every rooms, each and every halls. So naturally, from outdoor machine to indoor machine, whatever length we are, whatever path we are following it up, the copper pipe length will be definitely based on the length of the rooms, based on the halls. So naturally, copper pipe will be higher as compared to the conventional air conditioners, because in the case of conventional air conditioners, what we do, we try to avoid all those, and the unit is installed with the nearest outdoor machine locations. All the indoor units is installed with the nearest outdoor unit locations available. So we used to minimize the copper pipe. Whereas in the case of our VRF systems, outdoor unit will be located at only one place, and the copper pipe goes to various indoor locations. So definitely copper pipe will become little bit higher. But again, this is the initial cost basically, initial expenses basically. I think
Okay.
there was some other part of this question, something.
No, sir. Actually, they were discussing it with themselves only in the chat.
हाँ, because I mean say वही इंडोर जो यूनिट है ना, वो अलग अलग लोकेशन के चलते कॉपर पाइप लेंथ इंक्रीज हो जाते हैं इससे.
Okay, sir. आज का last question from Abhishek Bauchkar. He's asking how to select between chiller and VRF in commercial sector, and what are the limitations of VRF?
I have shown my one of the slide where we have shown outdoor capacity some manufacturers is having the limitations of 24 HP. Some of the manufacturers is having the limitations with 26 HP, and one of the Indian multinational company is having the limitations with 28 HP. So 28 HP into module of 4 can be clubbed at one place. So 112 HP capacity can be installed at one location, clubbing 28 HP into 4 machines. So we can get up to 112 HP at one machine, from one machine capacity basically. So but whereas in the case of the chillers goes with different and higher capacity also. Chillers, we have the limitations. The smaller capacity will be scroll chillers. We have screw chillers. We have century chillers. We have many other varieties of chillers. In the chiller, we can go the capacity till up to 4,000 tons. Also, the maximum capacity what I have heard, and I have heard through one of the manufacturers. तो उतने टन की कैपेसिटी तक हम जा सकते हैं एक ही आउटडोर मशीन से, एक ही चिलर कंप्रेसर मशीन से, कॉम्बो ऑफ देयर कंप्रेसर्स. लेकिन वीआरएफ की लिमिटेशन है कि 112 एचपी की कैपेसिटी तक हम कॉम्बो बना करके जा सकते हैं, फिर उसके बाद सेम कॉम्बो हम रिपीट कर सकते हैं.
Okay, sir. Yeah, thank you so much, sir. Now over to you, Neha Patil ma'am, for the conclusion.
Thank you, Meet. It's my privilege to propose a vote of thanks. I am Neha Patil on behalf of Mechanical Department extend a very hearty vote of thanks to Honorable Mr. Sanjay Verma, who took out valuable time from his busy schedule and joined us for the webinar. He's been an inspiration to many students. Sir, today's presentation was very nice and informative. Thank you. As no program can be successful with a single person, I extend my big thanks to our convener, coordinators, co-coordinators, and our student coordinators too. Link to fill up the feedback will be provided in YouTube description as well as on Telegram group. So let us all meet tomorrow for final session. Thank you.
Thank you so much. And I also feel privileged getting opportunity for giving some paper presentation on this platform. And I really love the way Dhanawade madam used to do the proper planning, proper coordination, follow-ups. Amazing. I'm coming to Lokmanya Tilak College since 4 years. I hope, 4 years or 5 years probably. And whenever I used to come, we used to have a lot of healthy discussion for any topics with Dhanawade madam, Neha madam, and entire mechanical team. And I feel very much, privileged to come with this platform for giving the presentation on basics of air conditioning and VRF. Thank you so much, the entire teams, for giving the opportunity. Thank you.
Thank you, sir.
Thanks.
Thank you so much, sir.
फोटो लेने